Okay, guys, so what I want you to start with, okay, what I want you to start with is the exploration plus a little bit, okay? So I want you to do the exploration all the way down to right before it says extra, oh my gosh, to right before it says extra practice, okay? So you're doing the exploration all the way down here till right before it says extra practice, okay? All right, rock and roll. Okay, so let's look at the exploration. So it says, the statement says the temperature in Sweden is at least negative 10 degrees.
Whoa.
So if it is at least negative 10 degrees, is it bigger or smaller than negative 10?
Bigger.
It's got to be bigger, right? Can it be equal to negative 10? Yes, it can. So when I'm writing my inequality, I want to say x is bigger or equal to negative 10, okay? I want you guys to untrain your brains, okay? I want you to untrain your brains to always thinking that is a greater than sign, okay? I know technically it is a greater than sign, but what we have to pay attention to is not only what sign is there, but where the stuff is, okay? Because if I flip-flopped this and put negative 10 here and x over here, I'm not going to use the same sign, right? I still want x to be bigger, so I'm going to have to flip my sign around, and the equal to part is going to be the same. So when you guys are looking at graphing them, you have to pay attention not only to the sign, but also where the stuff is. And the way we like to accomplish that is always to think, don't look at the sign and say, oh, that's a less than sign, or that's a greater than sign. Don't think about that. You always want to read it from the variable. So regardless of which one of these I'm reading, I would start with x and say x is bigger than negative 10, right? Always think about the alligator. You guys have all heard the alligator analogy, right? Alligator eats the bigger meal. So if you imagine that the inequality sign looks like an alligator's mouth, it's always going to be eating the bigger meal, right? So regardless of which one of those I'm reading x is bigger than negative 10, okay? On my graph, my dot is going to be at negative 10. What kind of dot is it going to be? Closed dot, right? Closed dots mean equal to. So since this one, it has the equal to part underneath, it is going to be a closed dot at negative 10. Okay? And then I want to shade bigger, so the bigger values are over this way. Okay? All right, let's look at the second one. So it says the elevation E. Oh man, did it give me? Oh, it gave me a variable over here. I didn't catch that. Why'd you guys let me miss that? It gave me the variable, didn't it? Okay, it gave me the variable of T over here. Sorry about that. All right, let's go back over here. So the elevation E of Alabama is at most 2,407 feet. So does that mean it has to be bigger or smaller than 2,407? Smaller. If it's at most 2,407, it has to be smaller than that. Can it be equal to 2,407?
Yes.
It can be, right? So E, my variable, has to be smaller or equal to 2,407. Or again, if you flipped them around, 2,407 and E over here, E has to be smaller, right? So E is smaller than 2,407. All right, so I have my, again, closed dot at 2,407. I'm just going to approximate here, right there-ish. Okay, and then E is smaller, so I'm coming back this way, smaller. Okay, comfort level just right up front. Comfort level, how you're feeling right there. 3, 2, 1, 0. Number 3 is mastery, 2 is near mastery, 1 is needs improvement. Good, okay. All right, let's look at the signs, okay? Let's look at the signs. So we talked about this a little bit. The only thing we didn't talk about is the equal to part or not, okay? So the first two is x is less than and x is greater than. Those are not equal to, right? So we do not have the equal to line underneath. So we want x is less than or x is smaller than 2. X is bigger than 2. Those do not have the lines on them. What kind of dots are those going to look like on the graph? Open dots. Okay, so let's go over here and graph those. So I have an open dot at 2, And this says x is smaller than 2, so I'm coming back this way. Oh. There we go, smaller than 2. Another open dot at 2. This one says x is bigger than 2, so I'm coming over to the right-hand side. Okay? Then we get to the equal to part, and that's where we have the equal to line, right? So x is less than or equal to, x is greater than or equal to. And then on my graph, those would be the closed dots. Okay, so closed dot at 2. X is less than, so coming back this way. Closed dot at 2. X is greater than, coming back that way. Or coming over that way. Okay. Alright, so now that we know what all of our signs mean, now that we are able to figure out the less than, at least, those types of words, I want you guys to practice that, okay? So practice that by using the words that we talked about up at the top. Practice that using the signs that we just talked about there. Try to make sure, as you are working through 1 through 4 together with your groups, try to make sure that you know when you are supposed to use the equal to and when you are not. Okay, that's what you really want to focus on. You're just writing an inequality. Okay, so go ahead with 1 through 4 down at the bottom of that page, and then we'll come together in a few minutes. Go ahead. Okay, so 1/3 of a number h. So 1/3 of h is less than, is it equal to? No, because it doesn't say equal to 15. Okay, plain and simple. The sum, what's sum mean? Add them together. So the sum of u and 14, so u plus 14, okay, is more than, so more than, is it equal to? No. 6. Done there. Okay. Any questions so far? Okay, number 3. 12 is greater than or equal to, so this one is the equal to part, right? 5 times a number n, so 5n. And then last but not least, 7 is less than or equal to, so again, it's going to be equal to the difference, so difference means subtraction, of a number q and 6, so q minus 6. Done. Okay, any questions? Pretty straightforward, right? All right, let's look at the second page. Okay, so let's touch base about what a solution means in an inequality, okay? So let's take a step backward. When we have an equation, okay, say, let me just pull over to the side here. If I have the equation x plus 1 equals 10, what would I do to solve that? It's not a trick question. Just subtract 1, right? So I have x equals 9. How many answers to that equation are there? Just one answer, right? One answer, that is 9. That's the only answer, right? If I switch and now I say x plus 1 is less than 10, you guys all know that I do the same steps of solving. We're not really going to get into solving today, but I'm just doing this for an example. And I get x is less than 9. How many answers are there to that inequality? There's a whole bunch, right? X is less than 9. I could use 8. I could use 0. I could use negative 50. I could use negative 500 million. I could use 8.99999999999999999999999999999999999999999. 99999. No, I'm just kidding. Okay. What I'm trying to get you to understand is there's a whole bunch of answers, right, that I could use for this inequality. So that's what you have to realize, guys, is when I'm talking an equation, when you solve an equation, unless it's a special case, when you solve an equation down, you generally get one answer, right? When you get an inequality, or when you're solving down an inequality, you get a whole grouping of answers, right? Any number that is smaller than 9 would be an answer to this inequality, okay? So essentially, when we were trying to figure out solutions to equations, we would plug the number in and see if the equation was true, right? So now we can choose any number less than 9 to see if that equation is true. Or in problems like 5 or 6, so let me get rid of this stuff. Oops, what am I doing? Okay, in problems like 5 and 6 up here, it asks me if 19 is an answer, is a possible solution to this inequality. So I plug it in just like I normally would, right? So I'm going to plug 19 in for D. So I have 19 minus 7 is less than 12. And I see if that's true. So what's 19 minus 7? 12. Is 12 less than 12? No. Okay. So 19 is not part of that solution set. And we generally call it a solution set because there's a whole bunch of them, right? What would have to be different about this sign in order for 19 to be part of the solution set? Yeah, Nolan. Yeah, well, less than or equal to, right? So it's less than right now. If it was less than or equal to, then 12 would be part of the solution set. Or excuse me, 19 would be part of the solution set, but it's not, okay? You guys go ahead. I'll give you like 20 seconds. Do number 6. Okay, so I plug 1 in. 3 times 1 is 3, plus 6 more is 9. Is 9 greater than or equal to 9? Yes, it is, because of that equal to part. Okay? So n equals 1 is part of the solution set. Okay? So if you plug it in and it makes the equation true, or excuse me, the inequality true, that's when I know I have a piece in the solution set. Okay? All right, so now what I want you guys to do is I want you to do 7 all the way through 14, okay? So you have 4 problems where you're actually graphing them. Make sure you pay attention to open or closed dot. Make sure you pay attention to where the sign is telling you to shade. And then I also want you to do 11 through 14. So 11 through 14, you are creating the inequality from the graph. Those are 2 separate skills that you must be able to do this unit, okay? You must be able to graph, and you must be able to write an inequality from the graph. So I'll give you some time. Mrs. Fisher and myself will come around and help you guys out. Let us know if you have questions. Okay, you can check your answers to the first 4 on the board. For number 7, I'm obviously starting at 3. I have a closed dot because it's equal to, and it tells me x is bigger, so I shade over to the right. For number 8, it tells me to start at 4. Again, another closed dot because it is equal to. It says x is less than, so I'm coming back to the left. Okay. Number 9 tells me to start at -1 with an open dot this time, right? Because there's no equal to part, so open dot at -1. And it says x is bigger, so I'm coming over to the right. And then lastly, number 10, I have an open dot again because there's no line underneath. And then it tells me x is smaller, so I come back this way. Okay. I want to add a couple more in here that I want you guys to do really quick before I go over 11 through the rest. Okay. I want you to try this one. Try that. Here, let me move it up some. And try this one. What did I do? I changed it. Sorry. What I have, 5 is less than or equal to x. Is that what I had before? Yeah. And then try -1 is greater than x. Okay, try graphing those 2. Just create your own graph. You don't have to have a ton of numbers on your number line. As long as you get the number in the middle where you're starting, one bigger, one smaller, that's fine with me. Okay, what's tricky about this problem? These 2 problems. Yeah, the x is on the other side, right? So remember, I told you guys in the beginning, it doesn't necessarily, well, it does, Does matter what the sign is, but it also matters where your stuff is, right? So you might be tempted when you look at this problem to say, oh, that's a less than sign, so I'm shading back to the left. But that would actually be incorrect, right? Because this says x is bigger than 5. Okay, so I'm going to have a closed dot because of the equal to part. And it says x is bigger, so we're shading over to the right. Okay. The second one, again, you might be tempted to say, oh, that's a greater than sign, so I'm shading bigger. Okay, but that would be incorrect, right? It says x is smaller than -1. So open dot since it's not equal to. And then x is smaller, so I'm shading back to the left. Okay, so that's why I really want to clue you in on paying attention. Okay, pay attention to where your stuff is. Always read it from the variable. Always read it from the variable. Okay? Any questions on that before we move on to 11? Okay, so writing the inequalities, okay? Writing the inequalities is an important skill, sometimes one that kind of gets lost in the shuffle, but it's important. So let's just always use x. I'm starting at 1. Am I shading bigger or smaller than 1? Bigger. So I want x to be bigger. Is it equal to? No, because it's an open dot. Okay? All right, x in 0. Am I shading bigger or smaller than 0? Smaller. And again, it's not equal to, so that's done. X in -3. I'm shading bigger than -3, and it's a closed dot, so I need to be equal to. So x is greater than or equal to -3. Okay, and then I have x and +3. I'm shading smaller than 3, so x is smaller, and again equal to because it's the solid dot. Okay. Any questions there? Y'all good?